So welcome back. This is also another video on the same elements and the periodic table. It's a wrong topic, so this is part number 5. So far we have done part number 1 up to 4. So this is part number 5. Chemistry from 2, element and chemical elements and the periodic table. So let us start by looking at the success criteria that we are supposed to cover by the end of this lesson, as well as by the end of this video. We are supposed to be able to state the uses of group 1 elements in the periodic table. So when we're talking about group 1 elements, we are referring to lithium, sodium, as well as potassium. We should be able to discuss using specific examples the pattern in physical as well as chemical properties of elements in group number 2. Remember, we've already covered the patterns as well as specific examples in groups number 1, where we are looking at the reactivity of them, which one is the most reactive, and what happened to their reactivity as well going down with water, and how do they bend. So all those are the patterns, what happens to elements in group number 1. But now we'll focus on the elements in group number 2. So the uses of, first of all, we're going to look at the uses of alkali metals. On the uses of alkali metals, we're going to focus on 3 alkali metals. The first one is lithium. So lithium, it is used to make lubricants such as grease. Lithium alloys, remember an alloy is combination of 2 metals, so it can combine with copper, which are used to build aircraft. Lithium-6 is a main source for the production of titanium. Lithium is used to make batteries, which contains more energy. So the batteries can be used in computer as well as cell phones. And sometimes when maybe you make a toy or drones, you can use the lithium battery. The salt, which is formed from lithium, can be used to make drugs which can stabilize the mood of a person. The second one is sodium. Sodium metal is used in preparation of tetraethyl read, an important antidote reagent in petrol. Sodium metal is used in the extraction of titanium metal from the titanium chloride. Sodium vapor is used in sodium vapor lamps. So these are some of the uses of sodium. It doesn't mean that these are the only ones. We can still search more on the resources that we're going to give you at the end of the presentation, so that you can check more. But these are some of the uses of sodium metal. We can also add with this one, sodium is used to make sodium chloride, which is a salt. Salt is used to add taste to the food that we eat. Usually in the relish we use salt. That salt is sodium chloride. So we can also have sodium carbonate. When we make sodium carbonate, since there is a presence of sodium in sodium carbonate, so it's used widely to manufacture glasses, detergents, as well as softening hard water. Sodium hydroxide as well as sodium chloride are used to manufacture soap and detergents. Potassium is used in making fertilizer, which is essential for plant growth. Potassium chromate is used as in tanning leather, in manufacturing of inks, gunpowder, as well as dyes. Dyes is used to color clothes and many things that maybe you want to change the color. Potassium hydroxide is used to make detergents, which are the soaps which we use for cleaning, such as Boom. We can talk about Sun, Shine, which are used for dishes. All those are in a group of detergents. Potassium nitrate is used as a food preservative. So from down from the group 1 elements, now we'll start focus on group number 2. Group number 2 is known as alkaline earth metals. Mark the difference. Group 1 is alkaline metals, alkali metals, while group number 2 is alkaline earth metals. They are called alkaline earth metals because their oxides and hydroxides are basic. That's why the word alkaline means basic in nature, and their oxides are found in the earth crust. So you can find the oxides of group 2 elements in earth crust. I'll just give you an example. If you take water down from deep down from the soil, maybe in the wells, though that water is hard water. When we're talking about hard water, it means it contains some minerals such as magnesium as well as calcium, which are found in the rocks. That's why we're saying that their oxide as well as hydroxide, they are going to be found on earthy crust. Members of group 2 elements include beryllium, magnesium, as well as calcium. These are the main members. Not from the big periodic table, but only for the first 20 elements, we're going to find 3 group 2 elements. That is beryllium, magnesium, and calcium. During chemical reaction, remember they will always undergo chemical reaction. These metals intend to form a charge of positive 2. What comes in your mind when we're talking about the charge of positive 2? Usually you can simplify that one by saying that during chemical reaction, they are going to lose its valence electrons. They are coming from group number 2. It means in their outermost energy level, they have 2 electrons. So during chemical reaction, they will always lose those 2 electrons and have a positive 2. They are the second most reactive metals of all metals. So it means the first reactive metal are alkali metals, which are group 1 elements. Physical properties of alkaline earth metals. These include they have higher melting and boiling points. If we were to compare with group 1, they have gray silver surface. They conduct heat and electricity. They are malleable. So the summary of the physical properties. So we can summarize in this way. We can check on the symbol. Beryllium, the symbol is Be. Magnesium is Mg. Calcium is Ca. This is the atomic numbers. These are electron configuration, but in terms of melting now and boiling point. We can check now on the melting and boiling point. Let us start with the melting point. Beryllium has 1278 degrees Celsius. While magnesium has 669, beryllium has 839, while the boiling point of beryllium is 2970, magnesium 1107, calcium 1484 degrees Celsius. So these are the summary of their physical property in terms of melting and boiling points. So trends in the physical property. Remember, we're looking at all of them and we check on their pattern as we are going down the group. So we'll check on the physical and chemical properties of them. Alkali earth metals have similar physical property and chemical property. It means on the chemical property, all of them undergo the same reactions. Beryllium is the only member of group 2 element that has unique characteristics. So when we're talking about uniqueness, we'll be able to tell what is it all about that beryllium has that other group 2 elements cannot do not have. So it behaves differently. This is due to the fact that their outermost electrons are strongly attracted to the nucleus. So if we go into electron configuration of beryllium, it has 2,2. It means now the outermost electrons, they are going only to be shielded by 2 electrons, which gives more ample time for the outermost electron to be strongly attracted by the nucleus. Therefore, what will be the impact? It is expected that beryllium will not form an ionic compound, since it is difficult for them to release the valence electrons which are strongly attracted. Therefore, it will form a molecular compound. So beryllium do not form cations. So that's what it means when we are saying it is having unique characteristics, different from other members, while other members will be able to form cations because they will be able to release their valence electrons. The reason why they are able to release their valence electrons means now the atomic radius increases. This makes their valence electrons to be easily released during chemical reaction. So the difference between alkali earth metals and the alkali metals, the difference between alkaline earth metals as well as alkali metals. One, alkali earth metals differ with alkaline metals in terms of their electron configuration. What do we mean when we're talking about in terms of their electron configuration? It's simply we focus on now the number of electrons which are found in the outermost shell. They will always differ in that. Group 2 elements will usually have 2 electrons in the outermost shell, while group 1 elements have 1 or a single electron in the outermost shell. So that is the first difference. They have different number of electrons in the outermost energy level. That's why we're saying that their configuration is different. Number 2, based on the reactivity, alkali metals, they are more reactive to compare with alkaline earth metals because alkali metals, they can easily release the valence electron, and usually for them to be stable, they only need to release a single electron, which is different from alkaline earth metals, which they need to release at least 2 electrons for them to be stable. So note, alkaline earth metals has to lose 2 electrons for it to be stable, unlike alkali metals, which needs to lose 1. Alkaline earth metals have strong nuclear charge to compare with the alkali metal in the same period. Therefore, it means it will hold the valence electrons more strongly to compare with the alkali metal. That's why the alkali metal are more reactive to compare with alkaline metals. So just to have a recap on the difference, we have said that they differ in terms of their electron configuration, such that alkaline earth metals have 2 electrons in the outermost shell, while alkali metals have a single electron in the outermost shell. Another difference we have based on the reactivity, and we have said alkali metals are more reactive because for them to be stable, they only need to lose a single electron, unlike alkali metal, which have to lose 2 electrons for them to be stable. Chemical properties of alkaline earth metals. Alkaline earth metals undergo the reactions similar to group 1, but are less reactive. Their reactivity among elements differs as well. The reactivity also increases as we are going down the group with the same reasons. Going down the group, the nuclear charge decreases. This makes the atom to lose the valence electron more easily. The most reactive element in group 2 is calcium, because its outermost electron is weakly attracted, hence can be easily lost during chemical reaction. So they react, the chemical property, the first one, they react with water to produce metal hydroxide as well as hydrogen gas, similar to what we discussed. So here, magnesium is reacting with water to form magnesium hydroxide plus hydrogen gas. Here we have calcium reacting with water to produce calcium hydroxide and hydrogen gas. But note, beryllium will not react here, because it is unable to form cation. Remember, we have already stipulated that, because it has strong nuclear charge which holds the valence electron strongly, and they cannot be easily released during chemical reaction. They react with air to produce simple metal oxides. So here they have always produced simple metal oxides because based on the reactivity, they are at least reactive to compare with alkali metals. So if they react with air, magnesium will produce magnesium oxide. Calcium will produce calcium oxide as stipulated in these equations. Solid beryllium do not react with air but powder. So it means if it is to react, you need to have a condition which is beryllium supposed to be in powder form. So beryllium can also react with air to form beryllium oxide. Not only calcium, strontium, and barium can form peroxides. So these ones are a little bit more reactive. That's why they are able to form peroxides depending on the amount of oxygen. They can react with chlorine to produce salt, similar to what we covered with alkali metal. They will be able to react and form a salt. For example, beryllium reacting with chlorine to form beryllium chloride, magnesium reacting with chlorine to form magnesium chloride, calcium reacting with chlorine to form calcium chloride, as stipulated with these three equations. So they react with dilute acid to produce salt and hydrogen gas. These are the equation. The first one, so here M plus HCl produce MHCl, which is a salt and hydrogen gas, where M can represent beryllium, magnesium, as well as calcium. The same applies with this one. So here we are just changing the type of acid, so it can react with the HCl, all of them, they can react with HCl. So where there is M, you can just be substituting with the metal of your own interest. They can also react with the sulfuric acid. They can also react with the nitric acid. Beryllium metal does not react with dilute acid because the metal is covered with a thin layer of beryllium oxide, which prevents it to form a reaction, but powder beryllium may react with dilute acid. Dilute sulfuric acid reacts slower with calcium because calcium sulfate produced is slightly soluble and forms a coating on the surface of calcium metal. Experiment that we can use to verify if the metal given is a group 1, is a group 2 metal. We can use the following experiment. This is a descriptive experiment, but remember, these experiments can also be carried out to verify and see what will happen. So the aim is to investigate the reaction of group 2 elements with water. The apparatus that we need beakers, we need distilled water, we need beryllium metal, we need magnesium metal, calcium, and pair of tongs. Procedure: measure reasonable amount of water and pour it in a beaker. Take a pair of tongs and pick magnesium metal and drop it in a beaker containing water. Record the observation. Repeat the steps A to C using calcium as well as beryllium. So the results: magnesium reacts slowly with water and calcium reacts fast with water. The solution formed from the reaction of water with either magnesium or calcium may turn litmus paper into blue, showing that it is going to form a basic solution. In conclusion, magnesium reacts slowly with water because it's less reactive, while calcium may react very fast and explosive with water because it's more reactive. Uses of alkaline earth metals. Start with beryllium. Beryllium alloys of beryllium, they are hard and strong with high resistance to wear. Therefore, it can be used to make computer parts as well as other instruments. It is used in transmission of X-rays. Beryllium is also a modulator of neutrons. That is, it slows them down, and it is used in nuclear reactor weapons. Magnesium metal. So this is magnesium ribbon. It looks like this one. You can see it is silver and is shiny. That is magnesium ribbon. So the uses of magnesium, it helps to maintain normal nerve and muscle function. Used medicinally as a common laxative and antacid drug, such as milk of magnesia. Usually it is used when someone has stomach pains where there is more acid so that it can be able to neutralize the acid. It also helps to adjust blood glucose levels. Magnesium oxide is used as a brick liner in furnaces, used in computer of radio frequency shielding. It is used as a reducing agent in the production of uranium and other metals. So another one is calcium metal. So this is how calcium metal looks like. The same color, silvery color, and is somehow shiny. So the uses of calcium is used as a reducing agent in preparation of metal such as uranium. Calcium carbonate is used as antacid tablet and the extraction of iron metals. How? Here in extraction it is able to remove the impurities. Calcium forms calcium carbonate, which is a component of cement. Mixture of calcium hydroxide, that is slaked lime, sand and water is used to make a mortar. Calcium oxide is used to neutralize acidic soils. Calcium is used in manufacturing of compound called calcium sulfate, that is plaster of Paris, which is used in hospital to support fractures. It is used as a scavenger agent used to remove impurities in metals, in the production of certain metals and preparation of various alloys. When added to lead, it produces a hard metal for storage battery grids, used as a reducing agent in preparing some of less common metals such as thorium. Now we have past session here. The questions that we are supposed to go through are based on what we have covered. Explain why calcium is more reactive than magnesium. Explain why beryllium does not form cations. Explain when an alkaline earth metal reacts with water, they produce a basic solution and hydrogen gas. Write the chemical equation to represent the reaction. So here you can use or is either all of them or any of the examples given based on the group 2 elements that we have covered. State 2 uses of the following metals: beryllium, magnesium, as well as potassium. So we can also have an experiment that we need to describe here. A newly discovered element X is suspected to be group 2 metal on the periodic table. Describe an experiment you can carry to verify if this one is a group 2 element. So if you have more questions, you can still reach us through xulendo.org. And if you answer the bus session, there will be some answer that you can still compare. But for more information about the lesson and the materials that we use to prepare the lesson, you can check or consult Excel and Succeed Junior Chemistry Book 2, Achievers in Chemistry Book 2, Target Junior Chemistry Book 2. The photos which we have used, these are the links where you can click and learn more about them. This marks the end of the presentation.